Now here I actually graphed that RT, and the RT I'm talking about is RT equals 2 sine t, 5t equals 2 cos t. So what we're seeing this helix, but it's a sideways helix. It's just coming around here, flipping around, and kind of going back around. It's going to keep doing it. It's going to keep spiraling, and that's what we're seeing there. So what I want to show you here is, if you look below here, I have T, N, and B, and I just kind of want to show you how those vectors actually work. So for instance, if I was at this point right here, my tangent vector would be shooting out this way. Now keeping in mind our N is interesting. It's always going to point to the inside of the curve. Now remember here, those are going to be orthogonal. And then we have our binormal, which shoots out of the top of this thing, and those have to be right angles as well. Oops. So that's kind of the idea with those. So those are all going to be right angles. Now one thing I want you to notice here is that the green, which is the N, is always going to point towards the inside of the curve. So that's a big deal here, and that's going to help us a lot. Now when I flip around the other side, now let's look at my tangent vector. Here, it's going to shoot that way. And the N, since this thing is curving in, is going to go this way. Now remember, that's 90 degrees there. So now we're going to put on there the binormal. And that's going to shoot straight up, kind of, in that direction. Now those are also going to be orthogonal. Okay, so what's happening is this green arrow, which is the normal vector, is always going to point inside to the inside of the curve. And what this binormal is doing, it's twisting around as it's going along this path. So one thing we use the binormal for is to compute torsion, like the torque of a path, or like the twisting of a path. Okay, and the N, again, is used to point to the inside of the curve. Some people say in concavity. And the T is always going to go in the direction of the path. So if you notice, my T is going in this direction. I should do the right color though. Is going here because we are traveling this way. Because we're going positive with this one. Because keep in mind, T is increasing, so it's going to go from 0 to positive. So it's going to shoot out this way. Now notice this. Here's the Y, and it's going along the Y. Notice my Y is the linear factor there, or linear term, I should say. So that's why it's going along the Y. So when I have a sine and cosine t, it's going to look circular there. Now if I took this graph and faced it right towards me, it would look like a circle of radius 2. And that's what we would see for that. So anyways, just kind of keep all that in mind together. So it's kind of nice. So the red here, that's just going to kind of be spinning around a little bit as it loops around and everything here. And then that tangent again is always going to, I mean not the tangent, but the normal vector is always going to point to the inside of the curve. And the tangent is always going to go in the direction of it. So there we go. It's nice sometimes to see the function you've been computing all these things with for the last couple videos. So there it is.